Maybe I'll give you 2 seconds of my background first so you understand the context of what I'll be talking about. So yes, I'm a professor at Syracuse University. I do research and consulting, but it's only been for the last 4 years. Before that, I worked full-time in industry as opposed to just consulting. So I spent most of my time in financial services doing machine learning, AI, predictive analytics before those were kind of common buzzwords. So worked on things like credit decisioning and risk management for banks for a number of years. What I'd like to talk to today is somewhat related to the previous talk. In the previous talk, there was a couple different things that was discussed. Data quality was mentioned a couple different times. Agile was mentioned once in terms of how his team would work. And then the fact that there was a team. So I'll be talking about those and many other aspects. The key that I'm going to be focusing on, which is different than most other talks, even last time, is I'm not going to be talking about the algorithms a data scientist uses. Those are important. The techniques that are used are obviously very important, evolving rapidly, deep learning. I'm not going to talk about neural networks or anything else. I'm going to talk about kind of from a manager's perspective or from a data scientist perspective about how to make sure that your project is successful. It's what I've seen often is neglected when people kind of focus on what I'll consider a shiny object, which is we've got AI, we have to use it. Maybe we have a couple of data scientists, we have some data. I think we have some data. Can we turn that into actionable insight? And then you forget to think that it's a project like any other project in your enterprise. And so at a high level, that's really what I want to talk about. I want to talk about how to think about machine learning and AI as any other project. Unfortunately, I won't be able to give you, here's 12 questions and here's the answer to those 12 questions. I don't have all the answers. I certainly don't have all the answers for all the different types of projects that are out there. What I can do is help you think about the questions you should be asking. And if you're working with data scientists or consultants or whatever it might be, questions you can ask them or kind of work through with them. So when I think of a framework, I wasn't thinking about here's the answers, but maybe a start to the questions. The other thing I'll point out is when I go through this today, I won't be talking about all the different things that you should be going through. Right? That would obviously take more than an hour. So I wanted just to highlight some of the key areas just to get your mind set on thinking through the types of situations and the types of questions that one should ask if you're doing a data science project. So why should you kind of think about this? Why do we need to think about data science and project management of data science, which was really kind of what I focus on? Well, there's 3 different reasons to think about it. In the end of the day, it's really similar to how people think about project management in general. So first is reduce risk. What do I mean by reduce risk? You're trying to reduce risk that the project will end in failure, and is one way to think about it. And lots of different ways that a project can fail. I've participated in many of those, learned my lessons sometimes relearned my lessons a couple times. But there's many different things that one should do, or one could do to reduce risk. And as a manager of data scientists and of kind of data science initiatives, that's kind of one thing to think about. Another thing is improve productivity, so make your team be more efficient. And again, if you're a data scientist, it's how can you be more efficient? And the third thing is improve insight. So it's one thing to finish a project, but then how do you know if you got the best insight possible? I'll give you a hint, you don't. It's impossible to know that answer, but you should be asking, did we do as much as we could have done? Because again, data science is very different than software. In software, you've got the app, you build the app and it works. Maybe the UI can be improved a little bit. In the day, it works or it doesn't work. In data science, you get an answer. Is it a good answer? Is it the best answer? It's not so easy to understand that. So that's what I want to focus on. So my approach to thinking through these challenges and questions or project management in general is to think through questions that one might ask. So I'll go through different questions and we'll kind of talk about them, category by category, if you will. And then we can think through ways to mitigate potential issues that might arise, ways to mitigate kind of issues that might arise. At the end, maybe we'll spend a little bit of time trying to prioritize, or at least have you think through prioritizing it for your project. Because there's not a one set of priorities for everybody. And as we go through these, some people will be like, yeah, that's a really important issue. Other people will be like, nah, I can kind of skip that one. And that's probably right. Again, it depends on the context, which ones are more and less important. So here are some possible things to think about. I kind of think about things from a risk perspective, again, because I used to work at a bank, so everything was about risk management. But we can see different types of things to think about. So in the previous talk, they talked a little bit about staffing, and I'll talk a little bit more about that. But one question is, do you have the right people on the team? And if not, what can we do about that? So another possible risk, and we probably could spend a few minutes talking about other possible risks. So one possible risk was suggested was either lack of definition or bad definition of success. And I think that's very much a potential issue, yes. So some projects, it's very clear. Some projects, it's more like, find insight in the data. I've got this survey data, for example, and I spent all this money, and now I can't really kind of figure out what to do with it. And there's various different types of problems. And so definitely one of the things to think about is how to make sure that your actionable insight, the team's actionable insight, is truly actionable by the client. And the client might be your boss, it might be your, an external client, it might be, the group that the data scientist team is working with, right? So I kind of view that as, does the data scientist team understand what would be actionable insight? And by actionable insight, I mean things that are operationable. So it's one thing to do great analysis, and at the end of the day, the sky is blue. Well, I can't really do anything to change the color of the sky. So the fact that you can tell me the sky is going to be blue, doesn't really help me, right? So weather prediction, for example, would be better. So depending on the context of the problem, the actionable insight might be different. But it is very, very important to understand that actionable insight. And to your point, that's not even listed here, right? So these are just examples, and there's many others we can talk through. Some other ones here that I talked about is, that I kind of briefly mentioned here, is bad data. Knowing if you have bad data sometimes isn't so easy either. But clearly, garbage in equals garbage out. But the question is, how do you know the quality of your data? How do you kind of work through it? Because you're never going to have perfect data either. So you have to kind of balance that and understand that. And maybe I'll just talk about one more before we move on. So number 5, they're not able to recreate the model or the analytics. This actually is a huge problem. If you talk to a data scientist and how they actually did their work, they're working in R, Python, some combination, maybe some other libraries. And especially if they're just 1 or 2 people, they create lots of different subdirectories of files and data sets, and they're working through it. And if you ever ask them to recreate somebody else's work, you'd be amazed how many people struggle to do that. And it's because it's not culturally, oftentimes, a key part of what they're trying to do. But if you can't recreate it, that can cause all kinds of issues about traceability down the road, or about maintainability as well. So we can kind of talk about different aspects of that. But something as simple as, can you recreate the analysis, is not so easy. And remember, to recreate the analysis, you don't just need the analytical code, whatever language it's written in. You need the data as well. Because running the same code on new data generates different analysis. So in many situations, that's not important, but in many other situations, being able to recreate what was done is very important. So these are kind of just some of the possible issues that one could run into. So again, every time I think of an issue, I try to think about it in terms of questions. Not answers, questions that the team can work through, questions that you can work through. So, and I try to think of them not as yes/no questions, so some of these are worded correctly, some of these can be improved, but you get the feel for this, right? So I'll pick on a different one, trying to pick on different topics that we haven't talked about yet. So how is the team ensured that bias is not in the decision? Well, actually, it probably is in the analytics. The question is, what have we done to minimize the bias? We could talk about bias for the entire hour I'm here, because there's bias in the data, perhaps. There's bias in how the data was collected, perhaps. There's bias in how the data scientist or data science team used that data, and the algorithms used, and the feature engineering, so kind of how the different features and kind of attributes were combined and not. So there's lots of different opportunities for bias. Sometimes bias is okay if you're doing segmentation of marketing. Oftentimes it's illegal, or at least kind of not a good thing to do. So that's a much harder question to try to answer. But I'm a firm believer if people talk through it, they'll do at least the most they can to try to minimize the impact of potential issues. So we try to think through different types of questions that we can do. Data quality is another one. How do you know you have good data? The previous discussion talked about having good data, but how do you know you actually have good data? And good data is a lot more than just how many fields are filled in or not filled in, right? Depending on the data sources, there's lots of different opportunities for noise in the data. Sometimes that's really important, how much noise is in the data. Sometimes lots of algorithms can kind of work through that to some degree. And that's where it gets tricky, because to some degree, how much does that mean? So these are just kind of some of the questions that we kind of can think through. So now we'll drive into each one of these in a little bit more. So I'll talk about team roles. So as we think of the composition of the team, I'll talk about the process the team can use, the different alternative processes the team can use. I'll talk about ethics, and that's where bias would come in, how to think through ethical situations that the team might encounter. I'll talk about quality and how to ensure the actionable insight is correct. Analytic workflow is basically tools and techniques to understand kind of the flow, or kind of how the analysis is done kind of from start to end. So conceptual understanding what was done for the analysis. Analytics and model management talks about being able to recreate a model from previous situations. So can you recreate what was done before? So if you're decisioning people based on an analytical algorithm, if you're making decisions based on an analytical algorithm, do you have a way to store that and then recreate that if you wanted to kind of go back to what was done before? And that could be from everything from decisioning loans, which obviously is very important to be able to recreate what you've done to make sure that you're not having discrimination, to a marketing campaign where you're trying different ones, test and learn, and you're like, whoa, that first A was really good. Can we redo that? It's like, well, maybe, maybe not. So how do you kind of have a library of models that you've executed? And the last one I'll talk about is production robustness. So sometimes we use data science and we just kind of want to get some insight and we move on. Sometimes we use data science and we want that data science to be part of the customer experience, and that kind of needs to be productionized. So the different levels of productionized, it might be a manager needs this once a week, or it could be it's within a website and it's being used millions of times a second. So everything in between there. But the type of analysis you do and how the team takes that analysis and uses it, turns it into actionable insight, if it's being used a million times a second or just twice, it might impact how the team actually creates their analysis. Let's jump into the first one. So roles. So the first thing I want to say is I'll talk about different skills. And clearly, one person can have multiple roles, but in my mind, it's always easier to think about it as multiple different roles. And that's because this avoids the problem of trying to find the unicorn data scientist. So there's a few really, really, really good data scientists that are really, really expensive, and if you're one of them, that's great. But if you're not one of those, or if you're a manager needing 5 or 6, it might be easier to think about what needs to be done and how to divide and conquer so you don't need an expert in everything. So here are some roles, and I'm sure if we brainstorm, we can come up with others. So again, this is not meant to be a definitive list. And I'll describe data scientists last, because in the end of the day, people think of the data scientists as being everything. So one is just about data architecture, how to store data, where it is, how much you need, how much history it is, how to kind of join conceptual, I'll call them data lakes, data repositories. So just conceptually thinking about data storage. A data engineer's role is typically thought of in terms of munging data. So that person or that team or that effort is often involved around programming, but is programming focused on being able to use data in a more effective way. A data or business analyst is often somebody or a role that's focused on understanding the business context. And I use business very loosely here, so it might not actually be a business, but it could be in any other domain. Understanding the domain so that the team can actually create actionable insight. So it's understanding how that might be useful. Then an infrastructure engineer or an IT infrastructure engineer or an IT engineer, lots of different phrases for it, that's a little bit more about production robustness. So if an algorithm needs to be put into production, what type of scalable infrastructure is required? So, and obviously at the end there's a client, somebody that actually is going to use this insight. So that's 2, 4, 5 different roles. And then the data scientist, the one I haven't talked about, well, many people think of them including all of these. What I think of a data scientist is the person that's using the data, using machine learning algorithms, some people call them AI, to generate the insight given the data. It's only a piece of the problem, though. So if you're just focusing on that, and you don't have all your data, you don't know where you're getting your data from, you don't know how to kind of clean your data, how to kind of integrate multiple data sources, just working on a deep neural network isn't going to do it. You need everything. So you need all these different skills. So this might be a team where there's one for each. It might be a team of one person that has multiple hats. You could have a team of 10 people. I've been on data science projects that kind of range from 1 to 25. So it really depends on the scale of the project. But in the end, you're going to need all of this at some point. Some of them might be pretty simple, and some of them, I've been on projects where kind of data architecture and data engineering was 80% of the effort. Because you need to get the data in a way that you can kind of then start using advanced analytics. Yes?
What is your opinion on whether the data engineer should have domain expertise or not?
So the question was, what's my thought on should a data engineer have domain expertise? I think that's a good question. In my experience, it's always good to have domain expertise. So if I had to pick between 2 people that were going to do that role, I would definitely pick the person that had domain expertise as well. However, it's not, I think, in many situations, required to really kind of be an expert in the domain. You need to be an expert in the data for the domain, which is a little bit different than the domain itself. So you need to understand what the different data is. You need to understand kind of the characteristics of the data feeds, for lack of a better word, even if they're not kind of real-time feeds. You need to understand all the data and the processes that need to happen, and you need to be technically excellent to implement whatever needs to be done. If you understand the context of how it's being used, it's good, but not required.
I would say that to also add to that,
Yeah.
The data engineer at least needs to care, about this, because if it's like a detached person, then no matter how good technical that person is, it's no use.
So the comment, in case you didn't hear it, was the person needs to at least care. And I would totally agree. Every one of these people needs to care, right? So if I have people on my team, I don't care if they're not, finance experts or whatever the kind of the domain might be. For some of these roles, it's important that they have that expertise, but all of them need to be passionate and interested, right? So if my data engineer is interested in the domain but doesn't have a lot of knowledge, I'm actually pretty good about that. But if they're not interested, then next. Exactly. Yes. Yes? Is it quite common to have the top 5 be one single person? I would say, in my experience, so different, your mileage might vary. In my experience, if there's only one person, the data scientist role will cover the top 2, 4, 5. Having said that, much more often, it's only the data scientist role and the data engineer role sometimes combined. So there's different permutations depending on the exact situation. Oftentimes, for example, there's a lot of infrastructure already there to do kind of MIS type reporting. And so there's people that can kind of fill some of these roles, at least part-time, to augment what a data scientist can do. And so sometimes an organization says, okay, so let me hire a data scientist or a consulting firm that kind of does data science work. And then they try to figure out what type of roles might they already have. Because if you look at that, a bunch of those roles, you don't need to be an expert in data science to do. And that, I think, is really important because finding a lot of data scientists is not that easy. But finding some of these others, well, if I don't have to kind of get everything, then it works. So I would say it's not that common. But for smaller organizations or kind of trial organizations, it would be. Was there another question? Yeah. So let me make sure I got your question right. So is it better to have like one data science team that works across multiple different kind of organizations or groups within the company or kind of, so yeah, so there's a trade-off organizationally. Do you have like a center of excellence in data science? Or do you have the data scientists embedded in each of the teams that might use it? I've seen both work, but what's incredibly important is to have the clients and the data scientists work as one team. So organizationally, you can do that a lot of different ways, but if it's throwing like requirements over the wall, like give me actionable insight from this data, and then they like, come back in 2 weeks and tell me what you got, that's not gonna work. So that can break in both situations, right? So even if they're in one organization, you can still have that attitude. And if they're in two different organizations, it can work or not work based on kind of the team-based approach, and I'll talk about that in a little bit, that the team uses. So it can make sense to have a center of excellence. That's how consulting firms work as well, because maybe you can't kind of support a full-time for kind of an ongoing basis doing analysis that makes sense. But you've got, a 6-month project to try to get something done, and then that expertise moves on to something else in the organization. So having a center of excellence can work, but it's critically important that they're considered as part of the kind of the domain team. So let's talk a little bit about the team process. Because if we have more than one person, and we will almost by definition, even if you're the data scientist, you have a data scientist and a client. It's almost never that the client is the actual data scientist. So I'll go through lots of different approaches, not lots, it's several. And we'll kind of talk about pluses and minuses and give you a feel for each. So the first one is Scrum. Many people use the term agile. The previous person who gave the talk in this room basically used an agile process methodology. And it has some good characteristics and some challenging characteristics. It's used pervasively in software development. So if you have knowledge and expertise or kind of know people that do software programming, a lot of them do agile development using Scrum. The basic idea on Scrum is you do a burst of work, which is called a sprint. And then as you go through, you kind of keep doing more and more functionality after each sprint. In software, that makes a lot of sense because after each sprint, you have something usable, you can kind of see it, and you can move forward. The problem with kind of doing these sprints in data science is that data science is exploratory. People like to think of it as kind of like a research problem that I need to kind of explore. So kind of having fixed schedules about a sprint that might be a week or two long can be very kind of difficult for teams to achieve. And so what typically happens when teams try to use kind of these sprints in a data science team is the data science teams misses the sprints because they kind of try to do something in 2 weeks and either, in 2 days we're done, or they're not even close to being done after 2 weeks, and so they kind of stretch it out. So they kind of lose the spirit of having these well-defined sprints because it's very hard to know how long exploratory analysis will take oftentimes. The other challenge with sprints are sometimes to collect data, it's a big effort. And so doing that in a short sprint is also very difficult. So there's situations where it makes a lot of sense, and there's situations where maybe it's not so great. Another process many teams use is called CRISP-DM. It's a waterfall-like process, so it's kind of like a stage. You kind of go from one phase to the next phase. So you'll start with kind of understanding the business context, understanding the data, doing some exploratory analysis. You can kind of see a flow there. And the challenge with this is it gives you a nice set of phases that the team should do. And the process kind of acknowledges that you might have to loop back. But it says nothing about how the team should work together. And it says nothing about when the team should be looping back. So conceptually, this makes a lot of sense. But if the team tries to do this, they're basically left to themselves to try to figure out what's the right way to do it. So some teams figure it out and do it the right way. And other teams kind of do this and kind of struggle through it and basically don't really do a process, but say they're using this type of process. Another type of process methodology is called KANBAN. So this process basically, you have a little board. The simplest one is to do, doing, and done. And you track what you're in the middle of doing, and you limit the work in progress. So you limit the stuff that's doing. And by having the team limit the stuff it's doing, you achieve agility because you kind of get something done and you move on, but you don't force it to be within a 1 week or 2 week time period. So if it takes 2 weeks, great. If it takes 3 weeks, that's okay. If it takes 1 week, that's okay. But everybody's clear on what the team is focusing on and what the possible to do things are, and you can prioritize that. So this is a very good way to kind of get everybody on the same page and not have to have specific deliverables at timed. The challenge with it, of course, is, well, that means you don't have milestones. So how do you kind of match those together? So there are processes that can work together, but these are three or four of the different methodologies that teams often use. I think at a high level, it's not important which one is being used. I mean, I can certainly point out pluses and minuses of each. I've certainly seen teams where we've created a methodology that works really well for them, but understanding what the team is using in terms of how are they collaborating together is most important. Just even asking the question. And to show you how important that question is or how frequently it's asked, so I've done some surveys in industry, and about 80% of the teams, when asked what process are you using, kind of go, we just kind of do it. So if there's 3 people that go, we just kind of do it, that means they're probably miscommunicating. That's 80% of the teams. In addition, about 85% of the teams, or people on data science teams, when asked, if you had a better defined, more well-defined process, would your team do better? 85% said yes. So it's a huge opportunity. And even if you don't pick the right one, it's kind of like if you pick anything, you're probably going to get at least half the benefit. And again, if you're a data scientist, you're at least working with the client. So have some kind of process to have the client understand what you're working on. Even if you just have a simple Kanban board. These are all the different things I could be doing. This is the thing I'm doing. Because then the client could be like, well, that other thing could be really cool. Even if that's all you do, you're going to get a lot of value compared to just, here, this is what I did. So the next category of discussion topic is ethics, and how to avoid an ethical conundrum, if you will, how to ensure that the analysis was done in an ethical way, a lot of different ways to phrase this. And when I think about this, I don't think about it as a society issue. I think those are important questions, but I don't think the data science team needs to address those. Right? So I don't think, for example, is self-driving cars good for the economy of Western Europe, the Western world, the world? That's a great question. That's not something that a data science team can answer on a project. But does your analysis bias a certain segment of the population is something that that team should understand. So I group these. And again, we could spend the rest of the time just on these. But I group the types of ethical questions one could ask into 3 high-level themes. First is kind of just like overall project related. Right? So how does the team know that there's actually ethical accountability in place? Because I'm a firm believer, if there is ethical accountability, a lot of this other stuff will just be at least asked. So you can ask that, right? So is there ethical accountability? How do we know no subgroup is going to be harmed by this analysis? And there's lots of different ways to do harm. So you can kind of ask these very high-level questions. I worked in banking, so there's obviously laws and regulations that need to be thought about as well. But even if there's not specific laws and regulations, you can still get your company in serious hot water if you kind of do things that perhaps others deem not appropriate. I won't go into examples because people might be in the room from those companies, but you can Google and you can find lots of situations where data scientists or the output of data scientists' work cause problems for an organization. And then besides kind of this overarching thing, you can think about data-related challenges and model-related challenges. So data-related challenges, I think, are not really specific to data science. But since data scientists and data science analysis uses data so much, it becomes at the forefront, right? So how was the data sourced? It's very easy in data science to use data that was gathered in a way that people didn't initially think that that's how the data was going to be used. I'm not going to say that that's okay or not, because it depends on the context. I'm going to say it's a fact that oftentimes data scientists get data, and it was released in a different context than the data scientists thought about. So that's kind of an example of that. Then model-related challenges are obviously very specific to data science. Is the model fair? How do you know the model's fair? What does fair mean? Again, there's not one right answer to that. If I have a model that identifies a certain segmented population that I should be targeting for, reduced prices on a certain product, is that fair? It depends. That's probably okay, but it depends on the context. Data science algorithms can certainly do that, can certainly identify price-sensitive personas of people and less price-sensitive personas of people. That's what airlines industry do based on when you buy a plane ticket. So there's lots of situations where I can create a situation where at least the question should be asked, is it fair? Model transparency is very different. Model transparency talks about, can you explain why the algorithm is behaving the way it is? Sometimes that's really important, and sometimes it's not. Sometimes it's important from an ethical perspective, because you have to explain why you turn somebody down for something. And sometimes it's important, not about ethics, but about convincing your stakeholders, your clients, that the algorithm is actually generating actionable insight, right? A lot of new and emerging algorithms, it's very hard to explain how the algorithm works. There's layers of nodes and there's weights, but you can't really explain intuitively why it's generating the analysis it's generating. You can explain the mathematics of how it's working. That's different than explaining the logic of how it's declining and accepting people. And so model transparency might be useful as a way to explain and give people comfort, and here's how the algorithm is behaving. So oftentimes when we think about model transparency, it might be around ethics, but it also might be around other things. And then there's questions about misinterpretation of the results. So I've been on projects where you've got one set of data scientists that analyze the data and come up with one set of insights. Another group analyzes the data and comes up with a completely different set of insights from the exact same data. It's not clear either was wrong, they just focused on different aspects, and at the end they came up with very different actionable insights. So kind of thinking through that is important. Data quality. So there's interviews with many different data scientists talking about data quality, lots of different things about that. I pulled one and I sourced it here in terms of discussions. So this wasn't like a one-line interview, but based on an interview with data scientists that were talking about data quality. Basically, the summary was, it's a hard problem. So these were expert data scientists. Here's some quotes. The world is a messy place. That's true. So you're not going to get typically very clean data. It's a tough problem. So it's not clean, and it's really not easy to clean it, right? If it was very easy, that wouldn't be very productive. One data scientist says it's not possible to ensure data quality, which is probably true. So the goal here isn't to say what's the process to get 100% quality data. It's what's the process to understand how our quality is and what we're going to do about it if it's kind of below a threshold, or to even understand what is a threshold that makes sense. In addition, sometimes cleaning the data distorts the data, or cleaning the data can actually just introduce bugs. Right? Oftentimes, the data engineer is going to be the person or the role that's actually cleaning the data. That means somebody's writing code to clean the data. Anytime anybody writes code, there could be a bug in that code. How do you know there wasn't a bug in that code? It sounds easy. It's an easy question to ask. It's not so easy to actually know that it's correct. There's things that one can do, but again, it's not like very simple to understand. Same thing with models. So models are oftentimes generated through code. Might be different than the code for cleaning, but it could be like R or Python code that's using machine learning libraries. How do you know that code's correct? So when we think about quality, it's not just about data quality. It's about ensuring quality overall of the model and the actionable insight. I've seen many clients look at actionable insight and not trust the results. And sometimes it's because they don't understand what's going on, and sometimes it's because no one's taken the effort to explain that the insight doesn't have an issue with it. Maybe there's a coding bug. If it's software, I can see the bug. If it's data science, well, maybe you're just giving me bad advice. There's other data quality challenges. Confirmation bias is maybe the one I'll talk about. Unfortunately, if you're kind of looking for a certain answer in data science, sometimes it might be easier to find that than if you just had a kind of a blank slate. Just kind of the way exploratory analysis works. So with the way the data scientist works and the way the team is working together to explore the data, look for data, pull data in, sometimes you can kind of confirm what your hypothesis is, even if that's not what the actual data is telling you, just by the way you're subsetting and looking at the data. So workflow tools are a way to help the team understand the flow of the data through the analysis. And it's one of the approaches that can put together code plus data in a way that's reproducible. So let me show you a picture of one of the tools. And I kind of have the name of the slide, name of the tool very small because I'm not endorsing this tool. I'm just using it as a representative sample. There's many tools like this. So basically, you have data coming in, you do different operations. So some of these tools are really good for high-level, kind of non-data scientist use. You're basically just dragging and dropping and doing things. Real data scientists get frustrated oftentimes by these tools because you want to do like lots of coding and you're kind of struggling to kind of fit it into this paradigm. So I don't want to say that any one tool is good, but looking through different types of tools, tools that are better for kind of data scientists that need to be coding, tools for kind of high-level data science analysis. But the conceptual idea is that if you can kind of map out the flow, that's one of the techniques that can be useful to help other people understand what the analysis was and to be able to reproduce it. So in terms of model management, this is an area that's often not discussed. The key here is, it's an audit trail. It's can you look back in time and see what you've done. In many situations, you don't need this. In many situations, this is required. But at least the team should be asking, do we need to be able to recreate not just the model, but an actual decision to explain it to somebody? Production robustness fits into the same area, which is to say that some teams don't need to worry about this at all. In other teams, this is the top problem, if you will, the top area to focus on, because the model that's generated is going to be built and then used repeatedly in some kind of internet-based situation, for example, or some sensors somewhere. So there's lots of different ways to think through how to build in production readiness, production robustness. Here's a simple example. Again, I'm not supporting any one tool, but the idea that there's different ways to actually see how the algorithm is literally performing in real time is something that some teams really need to think about. And so you need to instrument your models so you can kind of see how it's behaving. And other teams don't need to think about this at all. Yeah?
So dashboards are very popular, everybody wants them. Now, do you recommend to do all the data science work and then come up with a dashboard, or having the dashboard thought through before and then drive everything else from that?
So the question was, dashboards, I'll paraphrase. Dashboards are sexy and a lot of people like them. So do you, and sometimes they're really important. So do you create them at the end after you've built your model, or do you in some sense create the dashboard first and then almost work backwards from there? I would say two things. So if the data science output is going to be operationalized in a way that's going to be used in a production environment, at a minimum, the team should be thinking from the beginning about how to understand how it's behaving and how to know, for example, does the model need to be retrained? Is the model behaving as we were expecting? And so it doesn't necessarily need to be a fully defined dashboard, but the types of operational monitoring needs to be known. The fact that it's in a GUI, I don't really, that's not that important, but the fact that we need to be able to monitor these things We need to be able to ask this type of question once the system is in operation. That's really important. So I've gone through 2, 4, 6, 7 different types of questions, types of issues, types of challenges that teams need to be thinking through. Or if you're a manager of a team, you need to kind of make sure they're thinking it through. And if you're a data scientist, again, even if you're an individual data scientist, I would argue that you at least need to ask these types of questions. You need to communicate with your stakeholders, whoever they might be, that kind of here's how I think about this. So the question is, what is the right priority for these? And since we have a few minutes, I've got a little poll. There's actually 2 little polls. So if you take out your smartphones or your laptops, and if you want to spend like 2 minutes, that'll take you to a poll that basically you can just drag and drop the different areas of potential issues, and you can prioritize it. So I'll give people a minute or 2, since we have a little bit of time, to prioritize that. The first one that says ODSC 11, that's the one that kind of prioritizes it. The second one is just giving me a feeling for how many people are what type of skill sets. And as people are filling that out, I'll also take questions. I know people have been asking questions during it, so there might not be a lot of questions, but I'll take questions. Yes? So the question was about data architects and why is it important. Almost like everything else I've said here, sometimes it's really important and sometimes it's not so important. And the reason why I listed it as a role that can be very important is as the size of data sets grow, how the data is stored and how it can be accessed and how the size of the data scales over time can be an important characteristic of how the project is working. And so I view the data architect as the person that's in charge of how to store, terabytes, could be, we can pick any size data set we want, how to store all this information in a way that the data scientist, the one person doing the machine learning analysis, can actually access in an effective way. So there's lots of different ways to store data. NoSQL data stores, Hadoop infrastructure, for example. But there's other ways to do it as well. And so that analysis, that thought process, that's the role that I put around the data architect. Yes?
Just a question for you around recommendations for process management. So in my work, at least, we've tried KANBAN, we've tried Agile now, is where we're at, and we just have a hard time getting people to adopt that in their daily workflows. Do you recommend like a project manager manage that, or any recommendations on how to get people to actually use those tools, like D1 or something else?
Yes, so the question is really about, you've tried different process methodologies and the teams themselves are kind of objecting to using them or not kind of adhering to it. What I would say is if I was to sit down with those teams, I first would not force them to do anything because there's probably some reason why they're hesitant to use it. And so the challenge is that there's pros and cons to each, and need to understand kind of the root cause of why teams are not kind of adhering to it, right? So I've kind of given you some reasons why they all can kind of cause issues. And so I would sit down and try to understand and work with them about what process does make sense. So I didn't want to talk here, but there is a new process that I'm working on with some people that kind of does take this into account. So the idea that some of these don't work, have them define something that they think would work, because they need to buy into it. And having a process person on top of them, for lack of a better word, is a recipe for failure, and they'll just check the boxes and not really care about it. But if you work with them to try to really fix what the issues are, and you can kind of contact me offline and I can kind of share some insights, that's how I would try to approach it. So let's see if anybody's filled out the poll. That's fine. Is it going to work? There we go. Oh, it's really small. So let's see what people are prioritizing. So the number one thing people listed collectively was quality, ensuring quality. And the second was ethics, ensuring that kind of the team is thinking through ethical situations. So I'm showing this so you can kind of think about how your project or how you answer this relative to how kind of the collective group thought of this. I can't really say this is correct or wrong. The third one, I'll read it out because it's really small. Sorry about that. The third one is process, then role, then the workflow, production robustness, and the last one is model management. There's actually a pretty good grouping. So quality is by far the most important one. Then there's a big jump. And then ethics is kind of separate in number 2. And then there's the next 3 are pretty close: process, role, and analytical workflow. But certainly process and role are the next 2 that are pretty equal. So I think collectively there's a lot of science that actually says the team's collective view is correct. And I think that's actually, I would agree with that based on my historical struggles with projects. So I don't really have any more slides, so I'm more than happy to take additional questions or let you have coffee break 5 minutes early or 10 minutes early. Okay, thank you.